Okay, we're ready to do some bench testing of our motors and our drives. These are the KL5080Hs from Automation Technology Incorporated. These are the matching closed loop stepper motors with the encoders on them. And these are the extension cables for the encoders on these motors. It's very important to note that you must use these extension cables on the motors. Or if you try and plug this directly into the drive, it will not work. You have to plug it in through this cable. It's wired special. That's applying to these motors that have the cables coming out the side instead of directly out the top. If you have the ones that come directly out the top, it's a little bit different extension cable. So you need to be sure that you hook them up that way. In fact, I'm going to go ahead and hook them up now so I don't forget. And set it off to the side. Set these off to the side for now. Okay, here's our Acorn board, just as we bench tested it earlier. Still connected to the logic power supply. The one thing that you'll see a little bit different is I've got a stepper power supply connected. It's a 48 volt power supply. The max voltage of these motors is 50 volts, so I've got a 48 volt power supply here. So all I've done is I basically come off the AC side of the logic power supply and fed this 48 volt DC supply. So that's the only thing that's different from when we bench tested this earlier. So now we're going to go through the steps of connecting up Acorn to these to the stepper drivers and our motors here. One thing that I'd like to note is the terminals on Acorn, these are the inputs. They source 24 volts, and to activate them they need to be taken to common, all right? And in order to get the 24 volts to be sourced here, you'll notice when you look at them it says 24 volts in on this terminal here, which is I think that's H4 and this is H1, and there's 24 volts here. Well, internally on the board, the two terminals are tied together, so you only have to run 24 volts to this one or this one. So let's go ahead and do that now. There is a spare 24 volt terminal here on the terminal block, the input terminal block. And if you don't do this, these inputs aren't going to work. And we're going to go ahead and put it on this far terminal here. Okay? So the next step, let me back up a little bit. We want to use the schematic, the proper schematic for what we're doing. These drives are similar to the lead shine drives. So I've downloaded the Acorn schematic set from Centroid's website, and this is the schematic for the lead shine here. So we're going to use this as a guide. The difference is that these have a fault output where the lead shine does not have a fault output. Okay? So they're similar but not exact, but for the purposes of wiring it'll work. You know, let me zoom into the schematic here. Let's talk about these lead shine drives. These lead shine drives, you'll see it says pulse positive, pulse negative here, dir positive, dir negative, enable, NA, enable positive, enable negative. These drives require 5 volts to all the positive terminals. So if you go down here to the logic power supply, it says plus 5 volts, and our power supply outputs 5 volts. We're going to take that 5 volts up to enable plus, up to dir or direction plus, and up to pulse plus, which is the step signal. Okay, so we're going to feed them with that. And then we're going to take the negative side of these, negative side of enable, negative side of direction, negative side of pulse or step. Let's follow the pulse negative. It goes over here and it goes down to step ST1 on H2, and DIR direction goes over here to DR1 on H2, and then enable also goes over to enable negative on H2, and then our second axis will just go to step, direction, enable as well. Okay, so that's something I'm pointing out about these lead shine and lead shine clone drives. Now down here it says motor power supply. On these little drives here, it's right here. Here you see it a little bit closer. Here's where our stepper power supply comes in. There's volt, DC, and ground. And here's our motor, where our motor connects, and fortunately it's already wired, so we don't have to connect that. This is our encoder input. That's where the adapter cable is going to plug in. And then again, here's our fault output, enables, direction, and our stepper signals. We don't have to do anything with motor select, RS-232. None of this. We don't have to do anything like that. We don't have to program this thing. It's defaulted at 1,000 steps per revolution on the encoder count. So in Acorn, we're going to set that steps per revolution to 4,000 in quadrature, okay? Because that's what it's going to take to do one full revolution of the motor. So I just kind of wanted to go over this before we get started. So again, we're gonna do the 5 volts positive to the positive terminals here of the pulse, direction, enable, and then the negative side of these is going to go to Acorn to the respective axis. And then on a lathe, axis 1 is Z, and it's defaulted to axis 1 being Z and axis 2 being X. So this is Z, this is X. Now the other thing we got to do is hook up an E-stop button, and you'll see that right here. Our input 8 is defaulted to E-stop. We're not going to use these optional limit switches here, so ignore that. That wire is going to come straight over to our E-stop switch, and the other side of the E-stop switch is going to go to a common terminal, okay? And here's our E-stop switch. I've already got it wired. Use normally closed contacts on your E-stop, so if you buy these buttons, make sure you get normally closed. This is a spare set of contacts if needed. You can actually get these with just one set of contacts. It just depends on your situation. If you want, when you hit E-stop, you want to turn something else off or control something else, you can do that. And then all I got here is the other 2 wires. So we'll put the black to common, and we'll put the red to input 8. So let's go ahead and wire that up now. Okay, we've already got our 24 volt feed to our inputs. Now we're going to go ahead and take the black, and it's going to go to common. Here's common. And by the way, this common and these commons that are marked on the terminal blocks, they're all at the same, they're all connected internally. So this one here, we're going to go to input 8, IN8, not this one here. That would put a direct short. This is a 24 volt terminal. So do not hook your E-stop to that one. Hook it to input 8. All right, so that's our E-stop. E-stop is wired. That one was simple enough, okay? So we'll just set our E-stop off to the side now. I'm going to move this over to make a little bit of room. So now the next thing we need to do is we need to start wiring these drives up. Now I'm going to wire these drives up here for bench testing with shorter wires, but once I put them on the lathe, I will extend the wires. So it'll, all we're trying to prove now is we know initially we did our initial bench test, we got communications from the CNC PC to Acorn. That's established. So now what we're going to do is we're going to get the motors to turn. So we want to do all this on the bench, not on the machine. So we got our motors here on the bench. We've got our drives on the bench, we got Acorn on the bench, we got our stepper power supply on the bench, logic power supply on the bench. This is the best way to do this. It's easier to work on the bench. Once you get this nailed down and ironed out, then you can go ahead and put your motors on the machine, and we'll be doing that in another video. So anyway, let's get started. So let's go ahead and take care of this. Let's go ahead and connect our motors. I'm gonna put this one, since this is already pre-wired, Put that connector on there. So that's that motor. We're going to put this connector, and this is all going to get busy. I mean, there's going to be a lot of wire here, so just follow along. If you've got to stop the video or you got to back it up, feel free to do that. Because I'm actually, what I'm going to do is I'm going to end up stacking these on top like this for the sake of clarity and getting jumpers on here just to do the testing, okay? The next step is the corresponding, you want to mix these up. We want to put the corresponding encoder cable on the drive. We'll seat that fully, and it's a good idea to go ahead and cinch down the screws. Make sure you got a good connection, don't over tighten them. Okay, so that motor and drive's connected. Let's get this motor and drive connected. Okay, so that's done. Kind of set these kind of out of the way a little bit. Now what we want to do is I'm going to go ahead and hook up the stepper power supply to the stepper supply signals to the drive. So what I've done here is I've made up just a couple of jumpers, red and black, and we're going to put black. You can see here it says V minus, V plus, so we're going to put black under V minus. We're going to put red under V plus. And make sure, so there's 3 terminals for V plus, and there's the divider, and these are V minus, okay? So make sure you get those wired right. Now we're going to we'll go down here to we'll set this one off to the side for a second, work on the bottom one. We'll get a lead for ground. Put ground in there. Oh, that's the other thing, when you make your terminations, give your wires a tug to make sure they're fully seated in their connectors. Okay, that one's good. Now let's get our positive VDC. Put that in. Give that a tug, that's good. Let's do the same thing with this drive. Ground. Make sure these are all the way out so I can get them in. Okay. Ground. Okay. And our positive 48 volts. Give them a tug. Okay, those are connected now. Okay, remember what I said. Now we have to get 5 volts. Look at our schematic here again. We have to get 5 volts from the power supply up to these enable, direction, and pulse positive terminals. So let's go ahead and do that now. Got another jumper here, another wire made up. It's going to go to V1 on the power supply right here. V1 is 5 volts. Hook that up. Now, let's set this off to the side. I'm going to work on this bottom one here first. Like I said, it's going to get busy. It's going to get busy. A lot of wires. Just follow along. So this is 5 volts from our 5 volt power supply. We're going to go to pulse positive. Going to use a little jumper to also go to direction positive. I'm going to make sure I get this in there right. Yeah, there's the jumper. Let me get that one cinched down. Okay. And our jumper is in direction positive. Now we need another jumper to go from direction positive over to enable positive. Okay, see that? 5 volts from our logic power supply right here. It's coming off of V1. It's going over to pulse positive, jumping over to direction positive, jumping over to enable positive. So that one's set up, all right? Let's do the same thing to this one. The other 5 volt lead, going to go to pulse positive. Get a jumper. Snug down pulse positive. Get another jumper. Going to go from direction positive to enable. Okay. Now give them a tug, make sure everything's good. All right, so we'll set this one off to the side and we'll work on this one down here. So now we got our 5 volts to pulse positive, which is our step signal, direction positive, and enable positive, okay? So now we want to go ahead and wire, let's go ahead and wire this one to Acorn. So we're going to use, I made up this little cable, and I recommend that you use a shielded cable for these step signals, because they're high-speed signals. Use a shielded cable and ground the drain wire at one point. When you're building a cabinet, when you're doing a control cabinet, your grounds go to one point, whether it's a bolt or something like this. AC ground comes in, and all the grounds and all the shields go to one point. Do not ground them anywhere on your back panel or whatever. Bring them all to one point. So bring all your shield drain wires to one block. It eliminates what they call ground loops. So anyway, we're not using the black wire. We're just going to use these 3 wires. We're going to use red for step, blue for direction, and yellow for enable. So let's go ahead and hook those up. See if I get lucky enough to get them all in. Looks like I did. Okay, so step is red, direction is blue, and enable is yellow. So let's go over here to Acorn. It says ST1, red. That's step. DR1, that's direction. That's our blue wire coming from direction. The next one is enable, EN1. That goes here. Okay, so that cable is wired up. Now while we're here, let's go ahead and wire the fault. Okay, I choose to use a purple wire. Now, if we look at our schematic, this lead shine drive does not have a fault output, but our drives do, so we're going to use it. Input 5 is defaulted to drive OK, so that's the circuit that we're going to use. And remember, we got 24 volts coming out, and then these drives are going to ground or close the circuit if there's a fault. If memory serves, we'll find out here shortly when we set up set the drives up in the wizard. But for now, we're going to go ahead and wire them to input 5. So I'm going to use a purple wire. Here's input 5. We'll hook that up here. Okay. Now I'm going, because we're going to use one input and we have 2 drives, I'm going to put a jumper between the 2 so that if either drive faults, it'll put in a signal to Acorn. See if I can get them both in there. There we go. Now I'm doing this on the fault positive. Okay, so this is snug, this is snug. This is going to go to our fault positive, the other drive, when we get to wire it up. The other thing that we need on fault negative is we need a common. So we're going to go ahead and put a black wire. Same thing, black wire and a jumper. Here's that one. Here's my jumper. There, got them both in. See if I can keep them in while I tighten it up. Again, give them a tug, give them a tug. Okay, that's all good. So this one, this is going to be our fault for this one. So what do we do with this? We're going to take it to a common terminal. So any one of these common, unused commons we can use. So we'll just go ahead and put it on over here on this far common terminal. Because remember what I said, all the commons are tied together. So just think of this fault in these drives as a switch. It closes and opens. So 24 volts is going to go out to the drive, and it has to close it to complete the circuit. If it completes the circuit, that tells Acorn and the CNC software that there's a fault. All right, so we've got our first drive wired up. Let's get our second drive wired up. Let's start with these. Let's start with these loose. What did I do here? Here we go. Let's start with these loose wires. Fault positive. Okay, fault negative. Fault negative. This is called paralleling. So those are tight now, okay? Let's go ahead and get our signal lines hooked up. It's going to be red to pulse. I don't know if I get lucky twice. Yeah, I did. Give them a tug, make sure they're good. So we got red to pulse negative, blue to direction negative, and yellow to enable negative. Okay? So same thing over here the drive. Now, when we do Acorn, the next terminal is common. So the next one after that is ST2, and that's what we want. ST2. That's step, axis 2. And then we want direction, axis 2. And then we want enable, axis 2. Okay? All right, so we're all hooked up. Double check everything, red, blue, yellow, red, blue, yellow, red, blue, yellow, red, blue, yellow. So this top drive is going to be axis 2, that would be X. So this motor is going to be X, this one's going to be Z right here. Bottom one's going to be Z. So anyway, we got our common hooked up for our fault line, jumpers from fault plus to fault plus, fault negative to fault negative, and it's hooked up to input 5. We've got our e-stop button hooked up. So I think we're almost ready to fire it up. We need to configure the Centroid software, so I'm going to bring you down to the screen. And I'm going to move the motors over here because we're going to have a different angle now where you can see the display and then we can see motors running. And then we'll go ahead and configure the software using the Lathe Wizard. Okay guys, the next thing that we got to do is set up the wizard. And we're going to go into CNC Lathe Wizard. See if I can blow this up for you. And you see right here where it says select axis drive type, we were at bench test here. We're going to select lead shine. And down here it says first axis home limit OK. These are our limit switches so that we can run the software. We're going to set them to normally open. If they're set to normally closed, the software would see them as tripped, to limit tripped. So we're going to leave them that way. Okay? Leave them to normally open, both of them. All right. Drive OK is our input 5. That's already preset. It's set to normally open. If you may have to play with this, it depends on how the logic of your drive reports back the signal. But I think in the case of these automation technologies, it's normally open, and when there's a fault, it will close the circuit. So we're going to leave it to normally open. And then here's our e-stop OK, normally closed. That's standard. You want to use normally closed. We used normally closed contacts, so we're going to leave that to normally closed. Now let's go over to axis configuration. Right here where it says steps per revolution, they're 1,000 line encoders, and in quadrature you want them to be times 4. So we're going to put 4,000. This one 4,000. All right, the overall turns ratio, that's the drive reduction from the motor to the lead screws. We're going to set these or leave them at 1 for now, okay? So that if we want to command 1 revolution of the motor, all we got to do is say we command a 1-inch move, and we should be able to see the motor turn 1 revolution. All right, the rest of the stuff, the max rate, fast jog, and all that, we can leave these all at defaults. The direction reversal, we leave it at defaults. We're not hooked to the machine yet. Homing direction, homing sequence, we'll leave it at simple home. None of this has to be changed. Spindle setup, we have no spindle. We're not doing anything with that yet. Control peripherals, we're not doing anything with that. We do have a touch screen. We do have VCP, so we're leaving that on. Okay. And we're using the configuration menu password, Shuttle Express. We don't need to do anything with that. Advanced configuration. On these on a lead shine drive, when you choose the lead shine selection, it will invert the enable signals. This is where these signals, if your drive requires it needs to be inverted, it will invert the enable signals for lead shine, and it's required. Now these drives, I know for a fact, they don't need their signals to be inverted, so we'll just uncheck them. Okay? We're not doing anything with DB25 signal mapping. So at this point, we can double check things. First axis, second, they're all normally open. We've got drive OK, normally open. Input 8's normally closed, that's correct. Over here on outputs, we have no outputs connected to Acorn yet, so none of this is relevant, but this is where we would set up VFDs, lube pumps, flood coolant, that sort of thing. And they're all configurable. You can change them. We could set them all to unused if we wanted to, but there's nothing connected, so there's no harm done. We're going to write the settings to CNC control configuration now. Now, one thing, let me back up. I had to power up Acorn, so everything on the bench is now hot. The drives are hot, the motors are hot, Acorn's running. If you don't power up Acorn, you can't write the PLC to Acorn. Now we click Write Settings to CNC Control. We say yes, commit it, we close it, and now we should be able to open CNC 12 lathe. Okay, so CNC 12 is now open. You see the DROs showing dashes, and they're going to show dashes until we set machine home. Let's look in the message box. It says Z limit cleared, Z limit cleared. So they're cleared right now. We have no limit switches active. It says the next step is to set machine home. And if we didn't have limit switches, we would jog the axis to their home positions, and then we'd hit cycle start. So let's just hit cycle start, green button over here. Oops. Oh. I was trying to set home, and it says right up here at the very top, says emergency stop detected. So I'm going to release that, and there's emergency stop released. I'm going to hit it again, and there's emergency stop detected. There we are, released. Now we can set machine home. So I'm going to go ahead and hit our green button. It says machine home set, and our DROs are at 0. Now over here where it says incremental and continuous, when the button is lit, it's in incremental mode. That's incremental. We're going to go continuous, and let's just try and jog by pressing this. Okay, I see our motor moving. That's a good sign. That's a good sign. It's going back and forth. The other one is moving. This one is moving. Okay, I'm going to bring the motors into your field of view. All right, so you can see the motors, you can see the flags. I'm going to go over here and jog the axis. You can see our Z is moving here. And let's jog our X. So our X is moving, okay? I'm going to go ahead and I'm going to leave these little flags will be indicators as to a revolution. We want to turn 1 inch, should turn 1 revolution. So at this point, I'm going to go ahead and reset home. It'll zero out our DROs, all right? So now we're going to go into, and this is tortoise in the hair right here. I think I mentioned that earlier. Let's put it in fast jog. It says fast jog selected here. We're going to go in manual data input, and let's do a G0 Z1. So G0 is a rapid move, Z1 means move Z 1 inch. So our motor should turn, our Z motor should turn 1 inch. So to execute that, we hit cycle start, and you see it turned 1 inch. Okay? Let's go back the other way. We'll go G0 Z0. Execute the move, and it went back. Okay? Now let's try that with X. Let's do G0X1. Cycle start. Huh, it only turned a half a turn. Why is that? It's because we are in diameter mode. See the circle with the thing? We're in diameter. So because X on a lathe is going in to cut the part, if it takes a ½ inch off the part, it's going to take an inch off the diameter. So when you see this in diameter mode, that tells you that it's going to go basically half the distance because it's taking it off the diameter of the part. So that's why it did that. Let's bring that one back. So we go G0X0. Cycle start. I can hit the keyboard Alt S, or I can hit the green button. So, and it came back to its point. All right. So let me close this out. I want to show you a couple of things. I want to go back to the wizard, and we're going to make some changes in the wizard so you can see what happens if you misconfigure the wizard. So let's do one thing at a time. Blow this up so you can see it, hopefully. Now let's go to drive OK, and let's change this to normally closed. Okay, and that's the only change we're going to make. Right settings, yes. Okay, we're going to close this, and let's start at the CNC 12 lathe and see what we get. Look in our dialog box. Okay, our dialog box says, if you look down here, reset, it says tripped, and it says reset initiated, press reset to clear. When Acorn is powered up and you exit the software, when you come back into the software, you have to reset. So let's hit our e-stop, and then we'll release it. Everything in our dialog box looks good. Let's go ahead and go to MDI. Oh, drive fault. As soon as we go to an MDI, the enable circuit closes and it tries to enable the drives. So we got a drive fault. And if we were to look at the drives, there's no drive fault blinking. So that we chose the wrong contact input. So we need to exit this. Let's go back into the lathe wizard. Let's set drive OK back to normally open. And we're going to write the settings. Say yes, OK. Let's close the wizard. Let's go back into CNC 12 lathe and see if we corrected the problem. All right, at the top we still see that drive fault, and then we say reset initiated, press reset to clear. Well, we can hit the e-stop button, or we can clear it right here. Okay, so it's cleared. So let's go back in NDI. And let's do a G0X, let's say Z1. I'll do an Alt S for cycle start. And so our drive is cleared and it's working again, okay? Let's go back, G0, Z0, Alt S. Alt S is just a keyboard shortcut for cycle start. All right, so let's close this out again. Let's go back into the wizard, and we're going to work with the encoder setting, or the steps per revolution setting, I should say. Let's open this up where you can see it. Axis configuration. Now you remember I said that these motors have 1,000 line per inch encoders, and we put 4,000 lines, or 4,000 steps per revolution. So the encoder count corresponds with steps per revolution. However, if there's 1,000 line per count encoder in quadrature, you multiply that by 4, which is typical, and you put 4,000. Well, let's say you didn't do that. Let's say you did 1,000. And we're just going to do that to Z. I'm going to write settings. So you said, oh, this is 1,000 lines per revolution, so I'll put 1,000 lines in my steps per rev. So we say yes, go over here, and then remember, we're in overall turns ratio is 1. All right, that's important to note. Don't put anything else other than 1. All right, let's close this out. Start CNC 12 lathe. Remember, we only did this to Z, not X. Note where our little flag is, right here. All right, reset initiated, press reset to clear. Just hit I'm just hitting the reset button over there. You can hit it again, doesn't matter, and you can see it change, but it's cleared. So we'll go to MDI, and now we're going to do the same thing, G0Z1. Watch the flag. We'll hit cycle start up here this time. It only turned a quarter of a turn. So 1,000 lines only moves at a quarter of a turn. So we have to have that 4,000 lines. Let's go back, G0, Z0, Alt S. Okay, so we're back where we started. Escape, shut down, exit. Let's go back into the wizard. Axis configuration. 4,000. Okay. And again, let's play with this one. Let's say turns ratio. Let's say you didn't put it at 1. Let's say you left it as default of 5. You can imagine what's going to happen. Right settings. Yes. Okay. Close it. Let's start CNC 12 lathe. Okay, instead of hitting the reset button on virtual control panel, let's hit the e-stop button. Okay, cleared. Let's go to MDI. We're going to do a G0Z1. Now watch this motor. I'm going to do an Alt S. See, it turned 5 revolutions. Let's go G0, Z0. 1, 2, 3, 4, 5. 5 revolutions, okay? So there you go. We've successfully passed the bench test. Motors are working. Our KL5080H drives are working. These motors happen to be the KL23-2N1000 motors. So all this stuff's working now. So it's a matter of starting to fit up the motors to our lathe. So that'll be the next video installment. Talk to you guys soon. I hope you found this helpful.